Far beyond the reach of ordinary sunlight, past the bright orbits of Mars, Jupiter, and Saturn, there lies a pale blue giant, rolling silently through the cold night of the outer solar system. This is Uranus. It is often overlooked. Faint in the sky, distant in textbooks. A quiet member of our planetary family, seemingly unremarkable at first glance. But Uranus is anything but ordinary. It is one of the strangest worlds in the solar system, not because of what it has, but because of how it behaves. This planet doesn't rotate like the others. It doesn't orbit the sun the same way. Its poles don't sit upright, and its seasons don't pass in months. They span decades. Uranus tilts, but not just a little. It spins sideways, as if the laws of planetary motion simply forgot to apply. And that tilt, a cosmic oddity, transforms everything about the planet: its weather, its light, its seasons, and perhaps its very history. This is the story of a planet turned on its side, and the strange seasonal dance that has puzzled scientists for decades. Earth's seasons exist because our planet is tilted 23.5 degrees from vertical. That tilt gently shifts sunlight between hemispheres over a year, giving us winter and summer, spring and fall. But Uranus isn't gently tilted. It's almost completely on its side, its axis tilted at 98 degrees relative to its orbit. Imagine a spinning top lying flat as it rolls around a lamp. That's Uranus, orbiting the Sun. As a result, each pole spends 42 years facing the Sun and 42 years in complete darkness. That's not just a long season. That's nearly half a lifetime on Earth. If you were standing on Uranus's North Pole during its summer, you'd see the Sun circle the sky without setting for 4 straight decades. Then, just as slowly, you'd enter a night that lasts just as long. And during equinoxes, when the planet is side-on to the Sun, the sunlight dances across the equator in wild spirals, day and night passing rapidly, but at extreme angles. This isn't just strange, it's unearthly. A year on Uranus takes 84 Earth years to complete, which means the last northern summer began in 1965 and didn't end until 2007. We are only now watching the northern hemisphere emerge into spring. And with that change, the planet itself is beginning to awaken. When NASA's Voyager 2 spacecraft flew past Uranus in 1986, it offered humanity its first, and still only, close-up view of this tilted giant. But what Voyager saw was surprising. Unlike the stormy bands of Jupiter or the dramatic rings of Saturn, Uranus appeared quiet, almost featureless. Its atmosphere was smooth, calm, bluish. Only the faintest signs of cloud activity were detected. Many scientists at the time concluded that Uranus was simply inactive, a bland, frozen gas giant with little meteorological drama. But now, we understand that Voyager 2 arrived during the depths of southern summer, when the planet's southern pole was bathed in sunlight and the northern hemisphere was locked in decades of winter night. In other words, Voyager saw Uranus in a moment of stillness between the rhythms of its glacial seasons. And now, as spring advances and Uranus tips again, the clouds are stirring. The stillness is giving way to motion. Despite receiving less than a quarter of the sunlight that Saturn does, Uranus has an atmosphere full of movement, one that spins faster than the planet itself. Its winds, oddly enough, reach up to 900 kilometers per hour, especially around the equator. But why? Where does that energy come from? Here's the twist. Uranus emits almost no internal heat. Most gas giants, including Neptune, glow faintly in infrared. They radiate heat left over from their formation or from ongoing contraction. But Uranus? It's practically thermally silent. This makes it the coldest planet in the solar system, with temperatures dipping as low as -224 degrees Celsius. And yet, it has dynamic weather systems. Clouds form and drift. Bright spots, possibly massive storms, appear during seasonal shifts. In 2014, astronomers observed record-breaking storms during the northern spring, including one massive system large enough to span Earth. This suggests that Uranus's atmosphere responds strongly to the changing angle of sunlight. With seasons so slow, their effects take years, even decades, to develop. We're now witnessing one of those transitions. The planet is coming alive again. Why does Uranus spin sideways? The leading theory points to a cataclysmic past, a collision billions of years ago with a massive object, possibly Earth-sized or larger. That impact could have knocked the planet over, altered its rotation, and even disrupted its internal structure, perhaps explaining why Uranus has such a strange magnetic field and emits so little heat. This ancient crash might also explain the peculiar orbits of its moons and rings, which appear to circle the planet like a bullseye lying on a table, sideways, in line with its tilted equator. In this view, Uranus is a cosmic survivor, a planet shaped by trauma, bearing scars we are only beginning to interpret. Its tilt isn't just weird, it's a fossil of an ancient disaster. And that event continues to echo through every one of Uranus's seasons. If you could stand on Uranus, on a floating platform, above the clouds, your experience of time and light would be like nowhere else. During polar summer, the sun would never set, but it wouldn't be directly overhead either. It would circle the sky at an angle, never rising, never falling, just endlessly looping. During polar winter, the sun would be gone for decades. The sky would be a canvas of black, speckled with stars, and a faint ringed glow from the planet's own light. At equinox, the sun would rise and set rapidly, but in a strange pattern, tracing ellipses through the sky as the tilted axis pivots through space. And if you looked outward, you'd see Uranus's moons, each one rolling around the equator, orbiting like beads on a tilted wire. This is not a solar system as we know it. This is a solar system reimagined, where time itself bends around the physics of a sideways spin. Despite its strangeness, Uranus remains largely unexplored. Only one spacecraft has ever visited it, and for just a few hours, nearly 40 years ago. That's about to change. NASA and the European Space Agency are seriously considering a flagship Uranus orbiter and probe mission in the 2030s, a billion-dollar journey to finally study the ice giant up close. This mission would reveal its atmosphere, measure its heat, map its magnetic field, explore its moons, and monitor its seasonal changes in real time. It could answer questions we've long had. Why does Uranus emit no heat? How deep do its winds and storms run? What is hidden beneath those pale blue clouds? And could any of its moons, like Ariel or Miranda, hold subsurface oceans? A return to Uranus may be one of the most important planetary missions of the 21st century. Not because the planet is bright or showy, but because it is utterly unique. Uranus challenges everything we think we know about planetary behavior. It reminds us that the solar system and the universe is under no obligation to follow our rules. Planets don't have to spin upright. Seasons don't have to last 12 months. Sunlight doesn't have to rise and fall every day. Some worlds, like Uranus, move to a different rhythm. Its strange seasons are more than curiosities. They are windows into a different kind of world, one shaped by collision, altered by time, and slowly shifting in a dance that lasts lifetimes. For most of human history, Uranus was just a star in the sky. Now we know better. Now we watch it turn. Sideways. Silently. Beautifully. Waiting for the next season to begin.